Hi, everyone. Hope everyone is okay. Welcome to another Mr. X free class. We are doing physical sciences with particular emphasis on grade 12, and we are doing the topic of vertical projectile motion. So 2 hours of free class. It's going to get exciting. For some of you who are new here, my name is Mr. X Kolani Ndlovu. That's who I am, and I am a tutor teacher for mathematics and physical sciences. I have classes that I hold online Monday all the way to Thursday, 7 p.m. to 9 p.m., grade 10, 11, and 12. And we have 5 classes per subject per month. 5 lessons, 5 classes per subject per month. We're looking at 250 rands for those monthly classes per subject, where we learn all the concepts from scratch. We understand, we teach, we make sure foundations are done well. And then after that, we can do past exam papers, practice a lot, and make sure that we are thoroughly prepared. Speaking of which, I am currently doing the grade 12 physical sciences exam revision classes, 10 hours. Oh yeah, 10 hours. Paper 1, 5 hours. Paper 2, another 5 hours. And because today is the 11th of June, I've already done the paper 1 part, which I did yesterday, which was the paper 1 for physical sciences. Now I'm going to be doing paper 2, which is Monday, the 15th of June, and it's only 250 rands. All right, but if you want to do just paper 2 only, then you're just going to pay 125, because paper 1, I've already done it, and so forth. So this is what I do. Monthly classes, 250 that I'm going to be having. I have every single month, but also revisions as well. Now, very importantly, there are upcoming massive revision classes. Prelim revision, grade 10 to grade 12. Final exam revisions, grade 10 to grade 12. Now, for the prelim revisions, we are going to be doing 20 hours. Yeah, bo, you heard me. 20 hours per subject. 20 hours mathematics revision, 20 hours physical science revision. I will advise on the dates and the times and the monies for it when the time comes through. Final exams, that's really where it gets down. There, I will also do online classes. There, I'm thinking 25 hours of revision. Obviously, it can't be just one 25-hour session. It will be broken down into 5-hour sessions per day. So basically, that's what's going to happen for the online revision for the finals, grade 10 to grade 12. Also, massive face-to-face revision. That's going to happen only for the finals. So I'm a prelim, purely online. Finals, 2 options. We've got the face-to-face revision as well as the online revision. That's going to happen. So for the face-to-face, it's going to be 40 hours. 40 hours, 5 days, 8 hours a day. Massive back-to-back revisions as we prepare ourselves for the final examination. I'm also on social media. You guys can catch me out on my YouTube channel, which is the Mr. X Mathematics and Physical Sciences YouTube channel. I'm also available on TikTok, which is under the name Mr. X, as well as on Instagram, Mr. X Maths and Science. Speaking of social media, I'd like to appreciate you for 1 million likes on TikTok. Thank you. Really appreciate what you guys did. And also on YouTube, the likes, the comments, and everything. Really, really appreciate. I'm trying my best to make sure that you guys understand pass at affordable prices, and I can save you, as I always say, literally. So the information about all these revision classes, where they're going to be held, and blah, 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 I will update as soon as possible. Join my WhatsApp groups so that you can get all the information for everything. I'm based in Gauteng, so definitely the face-to-face classes will be right here in Gauteng. I will update on other places and other provinces what I'm going to do. But again, all this information will be updated and given to all of you as soon as is possible. Get to the WhatsApp group. It's going to be going down. All right. Having said that and introduced everything about me, let's do this. Let's do this. I'm ready, and I hope you're ready to now learn and start. My first question is a 2020 Mpumalanga paper prelim. I'm ready. Make sure that you're all seated and properly ready for this particular session. Write down the title, 2020 Mpumalanga prelim paper 1, and is question that is number 3. Now, here's the idea behind this topic. Whatever you do when it comes to vertical projectile motion, English is very important. English is very important. We translate the English into physics. That's what you do. Number 1. Number 2, your choice of the equation, whether whatever equation of motion you end up picking, your choice of the equation will always depend on the information given. So that's why it's important to list your information. What do you have? What do they want? And then you pick a choice of an equation. What do you have, as well as what do you want? That's very important. Having said that, let's get down to business. The story. A ball is thrown vertically upwards. So the ball is thrown vertically upwards at 8 meters per second from the top of a 21-meter high building. The ball reaches the maximum height of its motion at point X and returns to the ground. Ignore the effects of air resistance. So there's my diagram. I'm seeing the ball thrown. Now, keyword, whenever you throw a ball, whether you are throwing it vertically upwards or you are throwing it vertically downwards, the word throw will then tell me that its initial velocity cannot be 0. You cannot throw something and it starts with 0. You can drop it with a 0, but you can't throw it with a 0. And they did say to us here that the ball is thrown vertically upwards at 8 meters per second. There's a diagram, and we continue. 3.1. Is the ball in free fall at point X? Choose yes or no and give a reason for the answer. Point X happens to be the maximum height that the ball reaches. Maximum height. It is important to understand that when an object has reached maximum height, the implication is that its velocity is equal to 0. So the moment I reach maximum height, my velocity is 0. In English, the object stops at X. Maximum height at X. Now here's the implication. If the object has reached maximum height, if its final velocity at X is 0, is the object still undergoing free fall, as the question said? And it says choose yes or no and give a reason for the answer. The answer is yes. Yes, it is undergoing free fall. Why are you saying that? Is because the only force acting is the force of gravity. All right, let me say this again. Check it out. 3.1, what's happening? Yes, it's undergoing free fall. Why, say? Because the only force acting, or I can say gravitational force is the only force acting on the object. Now, hear me out. I want you to understand this clearly. When an object has stopped in mid-air, it is still undergoing free fall. When an object is at maximum height, it is still undergoing free fall. Actually, at maximum height, if you were to draw the free body diagram, it will show you that force of gravity is acting on the object and is acting downwards. So at maximum height, the object is undergoing free fall. Force of gravity is the only force acting. Also, oh, this gets interesting. Also, at maximum height, the acceleration, at maximum height, the acceleration of the object is 9.8 meters per second squared, and it's downwards. So understand, yes, your final velocity is 0. Yes, I agree. But still, within that circumstance, you are undergoing free fall. Within that circumstance, the only force acting on you is force due to gravity. Within that circumstance, you are accelerating at an acceleration of 9.8 meters per second downwards. And that's very important to understand. So 3.1, yes, gravitational force is the only force acting on the object. 3.2, let's keep going. So please don't forget that. There's many versions to how they ask you this. Sometimes they can say to you, what is the acceleration, or rather, what is the magnitude of the acceleration of the object at point X? The answer is 9.8 meters per second squared, and the direction will be downwards. Even at maximum height, I am still accelerating at 9.8 meters per second downwards. 3.2, something is coming up. Calculate the speed of the ball when it reaches the ground. Calculate the speed of the ball when it reaches the ground. Now let's do some logic. According to what we see, the ball was thrown 21 meters above the ground. So the ball goes up as far as point X, comes down towards the ground, and reaches the ground after some time. Our question is asking, calculate the speed of the ball when it reaches the ground. It is important under this topic to be able to choose a direction as positive. Okay, sir, you choose a direction as positive. It's up to you and your discretion. For some of you, you can say up is positive, or you can say down is positive. Doesn't matter. My suggestion, I would suggest that you take the direction in which the object is moving as positive. So our object moves upwards, and then it will eventually go down. So I will take up as positive. You are at liberty to do anything. So up as positive. What am I looking for? The speed of the ball when it reaches the ground. So right here at this moment, I'm looking for that speed. Let's begin. 21 meters above the ground, we were thrown. When I started, my initial velocity is 8 meters per second. So this is my starting velocity. It's a positive 8 meters per second. Why, sir? Because up is positive and the object is moving upwards at 8 meters per second. Fine. We're looking for the final velocity when the object reaches the ground. We are clueless about that. Since up is positive, that means my acceleration, which is due to gravity, must be equal to negative 9.8 meters per second squared. All right, listen to this. Acceleration due to gravity. Acceleration due to gravity always acts downwards. Acceleration due to gravity always acts downwards, regardless of whether the object is going up or down. Say that again, say. Acceleration due to gravity, yebo, always acts downwards, regardless of whether the object is going up or down. So since Tina, we are saying up is positive and acceleration due to gravity acts down, then it's going to be negative 9.8 meters per second squared. Sharp. How far did the object go? The object went down 21 meters. Down 21 meters, I will say. How far? You are saying to us the object goes from there, yebo, to point X, yes. Then from there, and this level, yes. At this level, I want you to understand that the total displacement of the object is 0 because it's right at the same level where it was projected from. Say that again, say. You're saying, Guti, from where we start until we get back to the same level. So from here to there, are you saying to us that the total displacement of the object is 0? Yes. So which means in essence, this ball went down 21 meters. Down is negative, down 21 meters. I've listed my information. I know what I want. I know what I have. I pick a choice. Your choice of the equation depends on the information given. I will pick VF squared is equal to VI squared plus 2A delta Y. Means to me, the VF squared, I'm doing the maths right here. So VI is a positive 8 plus 2, and then multiplied by my negative 9.8, multiplied by my negative 21, since the object is going down. And I'm thinking plus or minus. Remember when you square root, after getting the answer, when you square root, it must be plus or minus 21.81, according to my calculations, meters per second. Now, in truth to the word, hear me out. I want you to understand that in truth to the word, the velocity of the object will be negative 21.81 meters per second. But why say are you choosing negative? It's because by the time the object gets to the ground, it's moving downwards. And we said up is positive. So down is negative. So it's negative 21.81. But let's go back to the question. Calculate the speed. Speed is just a value without direction. You see, this negative shows me the direction, and so that's velocity. But speed, all you're looking for is the magnitude, so it's 21.81 meters per second right there. So write it down as an answer to that one. So do remember again, just to reiterate, the object goes down and it goes down 21 meters. The statement to remember, listen to my words. The statement to remember under this scenario is that the object will travel or move a height equal to the height above the ground where it was projected from. Again, I say, the object's displacement is the height above the ground from where it was projected from. So the object's displacement is the height above the ground from where it was projected from. So it was projected 21 meters above the ground and it went down 21 meters. Up is positive, your choice, and then negative 21 right there. Perfect. We keep going. I think we're still okay, step by step, and we take it up from there. So remember, you can always choose up as positive or down as positive, really up to you. Taking this out, there's a story on 3.3. I like to read the story because the more we do, hey, the more you know, the less you do, the less you know. Taking this out, it's gone. The story continues. The ball bounces on the floor and reaches the roof of an adjacent building 2.24 seconds after it bounced. 3.3, calculate the speed with which the ball bounces upwards. So here's the scenario. The ball gets to the ground, yes. Then it bounces off the ground, goes up, and the question says it reaches the roof of an adjacent building, which I see on the diagram, whose height is 9 meters. In other words, the ball moves upwards after bouncing 9 meters. Say that again, say. So it bounces, yes. And when it bounces, where does it go? Up. How far does it go? 9 meters up. How long does it take? 2.24. So I know how far it went. Up 9 meters, a positive 9. I know how long it took, 2.24 seconds to go up. I'm looking for how fast, or rather right, the speed. I'm looking for how fast it bounced upwards. That's what I'm looking for. So I know how long, 2.24 seconds. I know how far, that's 9 meters upwards. But I'm looking for how fast was it moving when it left the ground. Okay, sharp. You tell me, when the object is going upwards, is bouncing when it's going upwards, tell me, where is the acceleration due to gravity acting? Let me hear my people talking. When the object is going upwards after bouncing, where is the acceleration due to gravity acting? I want to hear my people talking. Downwards, you're correct. And we are still sticking to our guns. We are saying up is positive, so down still remains negative. So acceleration will be negative 9.8 meters per second squared. Say, pick a choice. My statement, your choice of the equation will always at any particular point depend on the information given. So I will pick a choice appropriate to what I'm looking for and what I have. The equations of motion. You get a mark for writing an equation. So it is almost practically impossible to get 0 in physics. But there are legends among us who can get 0. And I'm here to say, legend, I can save you from getting a 0. You don't have to. You don't have to. 9 meters, I see you. I see you. VI, I don't know you. Then I've got 2.24. That's the time taken to go up plus a half. Uchiwami is negative 9.8. Time taken is 2.24 squared. The rest, I tell you now, is algebra. It's numbers. That's all. You can confirm VI, the initial velocity, the velocity of the object going up. I'm getting 14,99 meters per second. You tell me. 14,99 meters per second. It should be a positive number. I'm going upwards anyway. Is it 14,99? It's about 15. All right, perfect. So 14,99 meters per second. 2 decimal places would suffice to the story. And that's what we are talking about. Somebody's asking, say, is 2.24 seconds the time is spent on the ground before bouncing, or is the time after bouncing? The 2.24 seconds is the time it's spent moving upwards to the building. I think the English says the ball bounces off on the floor and reaches the roof of an adjacent building 2.24 seconds after it bounced. So 2.24 seconds is not on the ground, but rather the time taken to get to the next building, which is 9 meters away. That's the 2.24. So the interpretation of the question is very, very important. All right, I'm ready. Hey, the more we do, the more we know. Let's try the other side of the same question. Now, true to the story, when it comes to vertical projectile motion, you may be asked to sketch graphs. So graphs like the velocity time graph, graphs like the position time graph. For 3.4, which is what I'm going to do now, we have a story that we have right there. According to what we see, the question says, draw a velocity time graph for the total movement of the ball since it was thrown until it reaches the roof of the adjacent building. Clearly indicate the following on the graph. All right, 5 marks is loading. Clearly indicate the velocity with which the ball was thrown. Okay. The velocity with which the ball hits the ground. Okay. The velocity with which the ball bounces upwards as can be seen. All right, I'm ready. Let's discuss. Now, when drawing the velocity time graph, if you are to catch the velocity time graph, my suggestion is write your velocity story. Tell me everything that happened velocitically. All right, there's no word like that, but velocitically. So here's the story. We started with a velocity of 8 meters per second. Naila, my story, 8 meters per second, a positive one. We went up to point X, and at point X, my velocity is 0 because that is my maximum height. We went to the ground, and when I got to the ground, we go back to the previous calculations. When I got to the ground, my velocity was negative 21.81 meters per second. So this is my velocity of entering the ground. My velocity of entrance into the ground. All right, say, siyakuzwa. Then when I left the ground after bouncing, my velocity of bouncing from the ground is 14.99 meters per second. I bounce and go up. According to the diagram, I go up and I will stop somewhere before getting to the roof of the top of the 9-meter building. All right, so I go up after bouncing. Somewhere I will stop. My velocity is 0. Then I go down to the top of the building, and the velocity at the top of the building, 9 meters, I don't know. Write your velocity story. So when sketching, before you do so, write your velocity story. Now, let me show you something interesting. When the object got to the ground, it was moving at 21.81 meters per second. That's the value. The direction is downwards, and down is negative from what we've been saying. It went up 14.99. Notice that when the object was on the ground, there was a change in the velocity of the object. The reason why there's a change in the velocity is because the object collided with the ground. So there was a collision between the object and the ground. Because of that collision, there's a change in velocity, a force is exerted, change in velocity, change in momentum, there's impulse on the ground. This is extra info. This is very important. I'm thinking velocity towards entrance velocity to the ground is greater than exit. I leave the ground with less than what I entered the ground with. How did I lose some of my velocity? The collision is inelastic, so therefore velocity of leaving ground, velocity of entering ground are not the same. Collision is inelastic. But I'm drawing my velocity time graph. I'm not the best person to draw anything. Those that I teach in my online classes, they know I fail a lot in drawing, so I know you draw better. Time in seconds, yebo se, and then here, velocity in meters per second. So the story, the velocity story. Where did we start? We started at 8 meters per second. Nailana, 8. I tick 8. That's where I started. Then where did I go? I went to a velocity of 0. So let's show it. It is a straight line. This is my velocity of 0. From 0, I went to a velocity of 21, negative 21.8. So I continue my journey, and my velocity touches the negative 21.8. So let me write it here as negative 21.81. That's my velocity when I enter the ground. Now hear me out. I'm going to collide with the ground. Now, something that we were not told. We are not told, Uguti, we spent time on the ground. So we don't know the time spent on the ground. We don't. In a case like that, you can show the collision with dotted lines. Dotted lines. Because when I'm leaving the ground, I leave the ground with a velocity of 14.99. So now 14.99. Here, I'm on 14,99. Let me just draw this and extend it a bit. Yep. So here we are. I'm on 14,99 right here. Look at it. The dotted line shows me the collision part. And in that context, I'm ready to say I've moved from 21.81 and to 14,99, a positive number. From 14,99, I go to 0. I must show it. I must show the 0. There we are. Then from 0, there, I go to an unknown value. So the unknown value of velocity is the one where I am at the top of the roof of the 9-meter building. Now notice where I put it. I put it less than the 21.81. Obviously, hear me out. Hear me out good. When I collide with the ground for the first time, this is where I get the best velocity. From there on, my velocity will decrease. The best velocity is right at the ground. From there on, I've got lesser and lesser velocity. I bounced, went up. As I go up, my velocity decreases until it gets to 0. Then I go down and hit the roof. And that velocity at the roof, by contrast, has to be smaller than the biggest velocity that we have, which is 21.81. It's a negative velocity as well, because when I hit the roof, I am going down, and down is negative. All right, say that again. Say that again. Uthini say. Are you saying, Uguti, I will bounce off the ground and the best velocity that I can get is when I hit the ground? From there on, I lose. From there on, I've got less. Are you saying that? Yes, that's exactly what I'm saying. Uguti, the moment the object has hit the ground, best velocity, what follows after is lesser and lesser due to the fact that there was a collision. And further, I went up, and as I go up, my velocity decreases until 0. Then I hit the ground, or rather hit the top of the building, 9 meters with a lesser velocity. And the question says, clearly show the velocity at which it was thrown, there. The velocity it hits the ground, there. The velocity it bounces, there. And further on as it is, and you get your 5 marks. So when it comes to the velocity time graph, it's always about writing your velocity story. Be careful. Do not confuse how the position time graph looks like and the velocity time graph in essence. So that's the story, and I'm sticking to it. All right. Let's keep going. I see people asking and also answering the questions. I appreciate. We are on the right track. Just to repeat, how do I draw the velocity time graph? Say, the velocity story. Tell me the story. The story says, I was thrown up with 8 meters per second. That's my story, and I'm sticking to it. Then I went up, stopped somewhere. My velocity is 0. Story. I went down. When I hit the ground, 21.81 negative, yes, because down is negative. Then I left, and I left with the 14,99, went up 14,99, got to 0 at my maximum height after the bounce. From there on, I hit a velocity on top of the building, and I really don't know what it is. All I know is less than the biggest, because every time I keep losing. So this becomes the story, and you just throw it. 8 meters, there we are. Now 0. Okay, then 21.81 is negative. the dotted lines signify a bounce. I bounce off with 14,99. There's 14,99. Then I go up 0. There's my 0 to the unknown, and there is my unknown. If you take down as positive, the graph is a reflection. What you see here is a reflection in the x-axis. So it reflects the other way around. Let's keep going. I have more. 2014 exemplar, paper 1, question number 3. I start on that one. 2014 exemplar, paper 1, and it's question number 3. And I'd like to start on that one. Here's the story, and I'm reading. Let's go. A ball of mass 0.5 kilograms is projected vertically downwards towards the ground from a height of 1.8 meters at a velocity of 2 meters per second. The position time graph for the motion of the ball is shown below. So I see the position time graph for the motion of the ball. I see that one below. All right, let me hear this out. So it is projected. So it's given an initial velocity, a projectile, an object that is given an initial velocity is projected. Okay, say, siyakuzwa. Projected how far? 1.8 meters. How fast was it projected? 2 meters per second. Sure. I look at the position time graph. Hear me out. The position time graph, exactly how you see it, is exactly how the object moved. So it looks like literally the object was here. It was thrown downwards and it went to the ground, hit the ground, spent some time with the ground, bounced off the ground, went to a certain height, then back to the ground, then spent some time with the ground, bounced off again, went to another height, then eventually back to the ground. How you see it is how it moved. The position time graph. Okay, sharp. I'm ready. 3.1. I'm ready. 3.1. What is the maximum vertical height reached by the ball after the second bounce? What is the maximum? I need you to answer this for me. What is the maximum vertical height reached by the ball after the second bounce? What are my people saying? Maximum vertical height reached by the ball after the second. Chuck Norris, second bounce. Read the question for what it is. Do not change it to you. Second bounce, 0.5 meters. I will say, Kanjani, I got your back. Boog and Dwana Boog. Between T1 and T2, that's my first bounce, I reach a maximum of 0.9. My second bounce, which is after T4, I reach a maximum of 0.5. So for 3.1, the answer is 0.5. So it's after the second bounce. Be careful, fam. Be very, very careful. 3.1, it's 0.5 meters. Perfect. So now I know what I didn't know. So for the first time, for the first time, I went 0.9. But the second time, it was 0.5. And remember, Personally, I was projected from 1.8. So be careful about that. That's 3.1. Thank you. You did well. Very proud of you. 3.2 says the following. Calculate the magnitude of the time T1 indicated on the graph. Calculate the magnitude of the time T1 indicated on the graph. Let's agree. The time T1 is the time taken by the object to reach the ground. Say that again, say. The time T1, yes, is the time taken by the object to reach the ground. So we're looking for how long the object took to reach the ground. I got your back. Follow my lead. Where were we? Delta Y. Okay, let's choose a direction. What was my advice? My advice was take the direction in which the object is moving as positive. The object moves down. So let's take down as positive. Down as positive. Okay, say siyakuzwa. Down is positive. How far did we go? 1.8 meters down. How fast were we moving? We moved at 2 meters per second downwards. All right. I hear you. All right. And then say, tell us more. Then what is my acceleration that is due to gravity? It's a positive 9.8 meters per second squared. Why is it positive? The object is going down. Yebo. Acceleration due to gravity x down. Yebo. Down is positive. So hear me out. If you are to choose down as positive, then automatically your acceleration due to gravity is a positive 9.8. If you are to choose down as positive, your acceleration due to gravity, which always acts downwards, is a positive 9.8. Always, by the way. And what am I looking for? I'm looking for time. Let's pick a choice. You got 3 choices, actually. Let me pick one which brings everything in the same sense together. So, I chose down as positive. I'm going to take delta y is equal to VI delta t plus a half a delta t squared. 1.8 meters positive down. 2 meters per second is how I started my journey. Plus half. The acceleration due to gravity is 9.8. It's a positive. Multiplied by delta t squared. Okay, sharp. Maths, we do. 2 delta t plus half 9.8 is 4.9 delta t squared, then 1.8. We have a problem. Delta t, don't know. Delta t, don't know. So what can I do? Say no more. I got your back. Rearrange, make it a quadratic. So it becomes 4.9 delta t squared plus 2 delta t, and then minus 1.8. So what I did is I rearranged and started with the t squared, and then there's the plus 2 delta t minus 1.8. It now looks like a quadratic version. Literally a quadratic version where the a, yebo, is 4,9. The B is the coefficient of delta T is 2. The C is negative 1,8. Then we can use the quadratic formula to be able to get our story. So it looks like to me delta T minus B, yebo, plus or minus the root of B squared minus 4 times A times OC negative 1.8. Now, I'm thinking you're going to get two values. One should be positive and the other should be negative times 2A. Please give me the values. One is positive, one is negative. You can do the maths. One is positive, one is negative. Give me the two values as can be seen. All right. Talk to me now. One is positive and one is negative. Let me hear you. Let me hear you. Let me hear you right there. I'm thinking in that case, I have 0,44. Thank you. And also negative 0,84. Judging by my story, time is always a positive entity. So my answer for the time taken is going to be a positive 0,44 seconds. All right, so write that one down, and that becomes the story in that instance. All right, all right. I'm ready. I'm ready. I'm ready. Talk to me. Talk to me. We're good? All right, all right. 0,44. There we are. Because the more we do, hey, the more we know. All right. That's 0,44 seconds. Let's try the next one, 3.3. So there's another way to get 3.2. You can do two equations. Like you can do the VF squared is VI squared plus 2A delta Y. Get the final velocity, then do VF is VI plus A delta T, get the time. So I chose to just go one way and then do the quadratic, as can be seen right there. Right, somebody says, say, how do we know VI is positive and VF is negative? I'm struggling with that. You chose a direction. The moment you choose a direction, now you know. You said down is positive. All right, let's learn. Let's learn. Down is positive. This 2 meters per second is the 2 meters per second for an object going down. And what is down? Down is positive. So that's why you put VI as a positive 2. It's aligned to the fact that it's a velocity associated with an object going down, and you said down is positive. That's my story, and I'm sticking to it. All right, all right. Here we go. 3.3. We run this through. Calculate for 3.3 the velocity with which the ball rebounds. Ooh, I like this. The velocity with which the ball rebounds from the ground during the first bounce. So I'm looking for the velocity with which the ball rebounds from the ground during its first bounce. I'm ready. Now, obviously, the object will reach the ground, and it's with the velocity that we don't know. Then it will spend some time with the ground. That's T1 and T2. It'll spend some time with the ground. That's T1 and T2. Then it will leave the ground. When it does for the first bounce, it goes up to a maximum height of 0.9 meters. And so we are asked to find the velocity at which it leaves, or rather, it leaves the ground. It enters, we don't know how much. We're looking for the exit velocity. So the entrance velocity, we're fine. What we don't know is the exit velocity. All we know, when we exited the ground for the first time, we went up 0.9 meters and we stopped somewhere, which means right at this point, my final velocity is 0 because I'm at maximum height after the first bounce. My initial velocity, I don't know. My delta y, I went up 0.9 meters, negative 0.9. I will say, why are you saying delta y is negative? Because I've been sticking to my story. That down is positive. So up would be negative. The acceleration that is due to gravity is still 9.8 positive meters per second, which is what I was alluding to. Uguti, the acceleration due to gravity will always be positive as long as you said down is positive. Mina, I'm looking for VI. Your choice of the equation depends on the information given. VF squared is VI squared plus 2A delta Y. VI, don't know you. VF, you are 0 at maximum height after the first bounce. The highest point after the first bounce, my velocity is 0. 9.8 delta Y negative 0.9. All I'm looking for is the initial velocity, which is the one that I have when I'm going up after bouncing right there. All right. The rest is algebra. The rest is maths. And we are sticking to the story right there. Talk to me. I'm thinking VI is a plus or minus after square rooting 4.2 meters per second. I think as a number, it has to be negative 4.2 meters per second. And if you want to put it even appropriately, showing them that you're going to varsity next year, then you'll say yebo, lapo, 4.2 meters per second upwards. There we are. That's your velocity at which it rebounds after the first bounce. Perfect. The more we do, the more we know. So keywords that are important, fam, is to keep understanding, Uguti, at maximum height, your velocity is 0. Aniti, when you went to the ground, spent some time at the ground, left the ground. When you did leave the ground, you went up first time to a maximum height of 0.9, where by confirmation, your final velocity is equal to 0. Now, somebody's asking, is it necessary to put the plus or minus? Yes. You know why I prefer that? So that when you are now choosing, okay, the idea is, remember when you square root anything, your answer is plus or minus. And so we are respecting directions in the context of our question. So the plus or minus is very helpful in the idea that I will end up knowing which, okay, it's a plus, it's a minus because up is negative, or you can write it and say 4.2 meters per second upwards. It also helps you even in the next calculations, once you've confirmed whether your velocity is negative or positive, depending on the direction. It will definitely help you. I'm ready. 3.4 is calling me. All right, it's calling me. I also want to call it. We are calling each other. The ball is in contact with the ground for 0.2 seconds during the first bounce. All right, I hear you. Calculate the magnitude of the force exerted by the ground on the ball during the first bounce. If the ball, so we're given a situation, if the ball strikes the ground at 6.27 meters per second. Logic, let's go. So we're looking for the force. What we're looking for force actually is the net force. We're looking for the force right there, which the object is going to be exert, or rather experience, when it collides with the ground for the first time. Understand that the collision will happen on the ground. They tell us that the ball strikes the ground, enters the ground with a velocity of 6.27, spends 0.2 seconds with the ground. All right. Then we know that it leaves the ground with negative 4.2 meters per second. The previous calculation right there. Okay, sharp. I'm ready. Here we go. So I go to the ground, 6.27. I leave the ground, negative 4.2. Question, calculate the force. I tell you now, your choice of the equation will depend on the information given. I go, net force, welcome to school, multiplied by delta P is delta T is equal to delta P. So net force times delta T is equal to delta P. This is coming from the how you define impulse. The whole idea of a collision brings the concepts of impulse, changes in momentum, changes in velocity, and so forth. I'm looking for net force. I might as well make net force the subject of the formula. So therefore, change in momentum is the mass of an object multiplied by change in velocity over time. So it's mass, then VF, I'm doing it old school, minus VI over delta T. The mass of the object, I'm thinking, is going to be 0.5. I'm given. There. The final velocity is the negative 4.2. Look at it. My exit velocity is negative 4.2. My entrance velocity is 6.27. So minus the initial 6.27. The time of contact on the ground is my 0.2, which in essence will give me a force confirm negative 26.18 newtons. They wanted the magnitude is 26.18 newtons. You can say upwards in that context. So hear me out one more time. What do we want? What do we want? We want the velocity, the net force of the object that it experiences when it is on the ground. We know that it is in contact, the ball, with the ground for 0.2 seconds. So the 0.2 seconds is the time of contact between the object and the ground during the first bounce. We're looking for the force. What do we know? We are told that the object strikes the ground, gets to the ground, strikes the ground with the velocity of 6.27. That's how I enter the ground. Nyangena groundini go 6.27. Nyangena. Then I leave the ground, which is what I calculated in 3.3 with 4.2. But say, why are you saying negative 4.2? It's because when I leave the ground, I'm going upwards, and up is negative because I've been saying down is positive. All right? Down is positive. So I enter with 6.27. I leave with negative 4.2. So my final negative 4.2 minus from the formula initial 6.27. Then over the time taken, I end up with my force that is exerted on that particular object. So that becomes the story right there. 4.2 from the previous calculation. Check what we've been doing. The 3.3, we got the 4.2 from there. This was the velocity of the object as it moved from there on. All right, I'm ready. The more we do, the more we know. Now it's clear. Someone says, say you're the goat. Danko posa. Danko posa. All right, so remember that in that context. Let's keep going. Ooh, beautiful. I wish we had seriously more time. Would have done even more. Now, so we're drawing now. Right. So we are drawing. It says to me on 3.5, which is us when we're drawing, draw a velocity time graph for the motion of the ball from the time it was projected to the time when it rebounds to a height of 0.9 meters. Then it says, clearly show the following on the graph. The time it takes when the ball hits the ground, the velocity of the ball when it hits the ground, and the velocity of the ball when it rebounds from the ground. So it's a velocity time graph, and it's always the most popular of them all anyway. And in this context, we are drawing it from when we started the journey. Remember, the story was from there. We went to the ground, spent some time with the ground, left the ground. They only want us to go as far as 0.9, which was our first bounce. So maybe we need to write our story velocitically wise. Our story velocitically. When we started, we were at 2 meters per second. We went down, and from the previous question, we went down and got to the ground with 6.27 meters. Spent some time with the ground, left the ground at negative 4.2 meters per second. We went up to the first highest point, 0.9 meters, where our velocity is 0. This is my story. Now, time. From the calculation that we did prior, we noticed that the time taken from where I was thrown from to the ground was 0.44 seconds. I remember that. When I came to the ground, I took 0.44 seconds. Now I am on the ground. I took 0.2 seconds. I remember these numbers because they told me that the time spent with the ground is 0.2 seconds. Then I left the ground. These are very critical times and would need them when we start sketching our graph. I'm ready. Here we go. I'm ready. Here we go. Check this out. I'm thinking there's my story, my velocity story. And where do I start? 2 meters per second, which is somewhere here. Maybe let me label seconds, time always on the x-axis, velocity, meters per second on the y-axis. My starting velocity is 2. From there on, I went to 6.27. So I tick what I've done. I went to 6.27. It's a positive. So maybe to show that, I have to have my line right there. How long did it take me to move from 2 meters per second to 6.27? The time taken was 0.44 seconds. So for time here, 0.44. Now it gets interesting. You see, we spent 0.2 seconds with the ground. And so imagine this. Imagine someone comes to class or gets into class at 8 o'clock, then spends 5 minutes in class. They must have left at 8:05. Okay, do the logic with me. 8 o'clock, I get into class. 5 minutes I spend in class. 8:05, I'm gone. The object gets to the ground at 0.44. Spends 0.2 seconds with the ground, which means the object left the ground at 0.64. Ayibose. Kanjani, bro. Yeah. I got to the ground. 0.44. Yebo say. And I spent 0.2 seconds on the ground. I must have left at 0.64. Okay. All right. So I went to the ground, 0.44. I spent 0.2. Then I must have left at 0.64. When I left at that 0.64, my velocity was negative 4.2. And so I need to show the dotted line, which gives me the bouncing. And this time, I will slant it. There's another way to write it here, but this time I'll slant it, showing me that there was time of contact. And so I'm at negative 4.2. From negative 4.2, according to my velocity story, I went up and I reached a velocity of 0. Okay, let me just extend my graph a bit here. So my time in seconds, I went up and I reached a velocity of 0. So there's my velocity. Right at that point, my velocity is 0. And so therefore, this is the velocity time graph for what happened in this particular context. So the dotted slanted line shows me that at a certain point, I spent some time on the ground. So that's why the time of contact was 0.2 seconds. So I came in at 0.44, left at 0.64, 0.2 seconds later. And then eventually, I got what I needed right there. Right. Perfect. The more we do, hey, the more we know. The less we do, the less we know. Let me put you on the tip end. I want you to try something. I want you to try. Okay? Try. Chuck Norris. Try. Do your best so that you can understand all of this. So again, as a heads up to the velocity time graph is always a story which I alluded to by the previous calculations. And I did say, Uguti, you started with the velocity of 2 meters per second. And you went down, entered, striked the ground with 6.27, left negative 4.2, and then they said as far as 0.9 meters, which was my first bounce, and at that first bounce, my final velocity would be 0. Then all you do is just pick the numbers from the story and just put them there. Wherever there's bouncing, do not forget the dotted line. We took 0.44 seconds to get to the ground, and then eventually negative 4.2, or rather 0.2 seconds on the ground, and we left at 0.64. It's just an addition in that context. I want you to try something. I want you to try. Pezwa. So I drawn it there. All right. I'm going to give you 7 minutes to try this. It's a situation where there's 2 balls. It's about to go down. 7 minutes. Try it, Chuck Norris. Let's see where we are. 7 minutes. Few more minutes. All right. Let's see how it goes and if we're on the right track or not. So sometimes you can get questions like this, which have got two balls, and sometimes they can move at the same time. Other times, after 1 second, 2 seconds, there's just so many things that can come out in this type of topic, which is why it's very important to practice a lot. And like I said in the beginning, that I have classes, online classes that I do for both maths and physical sciences every single month. Powerful things where we do a lot of questions. We learn the concepts from scratch, everything that is needed. And I'm going to be having massive revisions for the prelim exams and for the finals. So you better put your spot there because it gets a bit full. So it's going to get down from there on. All right, let's try and do this and see if we're going to win. There's a story I read. Two balls, A and B, are thrown simultaneously. So it means at the same time, there's no time lag. So they are thrown simultaneously from different positions of the balcony overlooking the streets. Ball A is thrown vertically upwards. So A, you go vertically upwards with the velocity of 5 meters per second from the top of a balcony. And ball B is thrown also vertically upwards with the velocity of 8 meters per second, but from the bottom of the balcony. Ignore the effects of air resistance. And so that's the story. We start off with the definition, 2 marks in the exam. Define the term projectile. So under this particular topic, most of the time, they will ask you to define a projectile. Also, they will ask you to define free fall. Those are two different things. But here's how the projectile definition looks like. An object which has been given an initial velocity, and then it moves under the influence of gravitational force only. That is what a projectile is. One thing for certain, listen to this. definitions are 2 marks or 0. So there's no part where you say, I know sometimes, halfway in between. No. You must know everything and write it as is. So that's an object given an initial velocity and moves under the influence of gravitational force only. 4.2. Calculate the maximum height reached by ball A above the balcony. So basically, we're looking for the height that ball A will move above the balcony. I would rather say up is positive. It makes a bit of some sense because the object ball A is going up. So let me take up as positive. This means, by extension, Uguti, I know my final velocity because when I reach maximum height, my final velocity is 0. I know my initial, and so I can get my maximum height. Your choice of the equation will always depend on the information that has been given. So final velocity is 0. I'm at maximum height. Initially, we moved with 5 meters per second upwards. So that's 5 squared plus 2. The acceleration is due to gravity. I'm going up. Up is positive. So acceleration, which x down, would be negative multiplied by delta y. So when I do my math, upon confirmation, the object goes up 1.28 meters above the balcony. So in other words, from here to the highest point is just 1.28 meters. Confirm if that's the answer, but I think that should be it. You tell me. But I think that should be it. Up we go. That's 1.28 up the balcony. All right. I'm ready for the next one. 1.28 meters above the balcony. Then 4.3 rather, 5 marks for 4.3. It says, if the height of the balcony is 5 meters. So in other words, from the ground to the balcony, it's 5 meters. If it's 5 meters, show by calculation where the ball B reached the maximum height reached by ball A. So 5 meters from the ground to the balcony. Question: if the height of the balcony is 5 meters, show by calculation where the ball B reached the maximum height that ball A reached. I'm ready. Think with me. I'm thinking, if indeed I've got 5 meters from the ground to the balcony, then ball A traveled 6.28 meters. I will say, yeah, it traveled 6.28 meters above the ground. Where'd you get that 6.28 from? I got your back. And it went up 1.28 from the balcony. So by comparison and contrast, the maximum height from the ground, maximum height of ball A from the ground, and it of A from the ground is the 5 meters. Already it was 5 meters on the balcony, plus the further 1.28 meters that it went up with. So it went up 6.28 meters. That's ball A. Question: will ball B calculate whether ball B will reach the maximum height reached by ball A. So I need to consider ukuthi B is moving. But B, I need to see if B will reach 6.2 meters. So let me get the maximum height of B. And the maximum height of B is always found when his final velocity is 0 meters per second. Anyway, the maximum height of anything is found when the final velocity is 0. So let me get how far he went. I'd like to know how far he went. All right, say, Peswa. Pick a choice. VF squared again. VI squared plus 2A delta Y. The final velocity to get maximum height of B is 0. Initially, B was moving at 8 meters per second upwards. So that's an 8 squared plus 2. Up is positive. We've been sticking to our story. So it means Uguti, OA is negative 9.8. And then I'm thinking all I need is to get delta Y. So let me get the maximum height of B. So when a B, you must have gone up with 3.27 meters. All right. So when A has traveled all the way 6.28, B, his maximum is only 3.27. And so therefore, to answer the question, show by calculation whether B reached the maximum height reached by A. Definitely not. Why say? Because the height reached by B is less than the one for A. In other words, 3.27 meters is less than 6.28 meters. So as a concluding statement, we would simply say ball B, Yebo, did not reach the maximum height reached by ball A. All right, let me stretch this a bit so that is visible. Yeah. Ball B, when ball B, you didn't reach the maximum height that ball A reached. So that becomes the answer right there. So remember, ball B was at the ground. It wasn't on top of the balcony. No, it was starting from 0 at the ground, went up, and its best it could do was just 3.27, while A, with an advantage of being 5 meters up the balcony, further went 1.28, and from the context of the ground, A went up. The maximum height of A is 6.28. It was already 5 meters above the ground, and further 1.28, while B was from the ground and it only reached 3.27 right there. I'm hoping that's fine. Did you get this right? Did you or did you not? All right. Did we or did we not? We did. Perfect. Because the more we do, the more we know. The less we do, the less we know. All right. So basically that's the idea. It's 5 marks. And maybe for the mark allocation, because someone is asking, for the mark allocation, this should be 1 mark for the formula, maybe a mark for the substitution, and maybe for the conclusion there. And then this one is pretty much what you see there. Probably a mark for this as well. So it's 5 marks. All right, perfect. I'm ready. Let's try the next one, 4.4. 4.4. I'm ready for 4.4. Let me know where there's a problem. So you can't, somebody's asking, so can we add 5 meters to B? No, we can't. Because B starts from the ground. The 5 meters is only for A. And B was started from the ground. So you can't add it. A had an advantage of being 5 meters above. But we don't really know, or would see, we only know B from the ground, but A from top of the balcony. So you can't add 5 meters to B. You can't, because B was from the ground. And so look at the answers, the questions, and the numbers so that you see where this is going on. Very important from there on. All right. I'm ready. 4.4. Calculate the speed at which ball B was moving when ball A reached its maximum height, 4 marks. So we were looking for the speed at which ball B was moving when ball A reached its maximum height. So here's the story. So while ball B is moving, ball A simultaneously moves and ultimately reaches a maximum height. The question is, when ball A has reached maximum height, how fast was ball B moving? So I'm trying to interpret the English there. When ball A reached its maximum height, how fast was ball B moving? Maybe the key is to find how long it took ball A to reach maximum height. Because think about it. When ball A is moving, let's say it takes 2 seconds. I'm just giving a number. When ball A is moving, and let's say it takes 2 seconds to reach maximum height, ball B is moving. And we can find out when ball A has reached maximum height in 2 seconds. In that 2 seconds, which is the time taken by ball A to reach maximum height, in that 2 seconds, how fast was B moving? So let me get how long it took ball A to reach maximum height, because the time taken by ball A to reach that height is simultaneous at the time ball B is moving. And so we are asked to find that speed that ball B is moving at while ball A reaches maximum height. That's why I'm insistent on getting time. How long does ball A get to the maximum height? Time. How long does ball A get to the maximum height? All right, let's think. Let's start with ball A and the how long. How long? So A, tell us how long you take to get maximum. So your choice of the equation will depend on the information given. I'm thinking, let me pick my guy. VF is VI plus A delta T. At maximum height, A, velocity is 0. A started with an initial of 5. Be careful of the algebra. Up is positive, so it's negative 9.8. So let me write it as, negative 9.8. Multiplied by the time taken. The rest is maths. I'm thinking the time taken by A to reach maximum height is 0.51 seconds. So this is the time that A takes to reach maximum height. But at the same time, while A is busy reaching maximum height, OB is going up. And go back to the question, calculate the speed at which ball B is moving when ball A reached its maximum height. So now know ukuthi OA takes 0.51 seconds to reach maximum height. So let me find out in that 0.51 seconds, how fast was B moving? How fast was B moving? I pick a choice. VF again. Okay. VI plus A delta T. I'm thinking I want to know how fast. Initially, B was moving at 8 meters per second plus U negative 9.8. And the time taken is 0.51, which is the time that UB, or rather UA takes to reach maximum height. So I'm thinking when A reaches maximum height, B is on 3 meters per second. All right. There we go. That's the story. And we are about to go on that one. So basically, that's 4.4. Did you or did you not? Talk to me now. Did you or did you not? 3 meters per second. That's the velocity of point B when it goes up, while, or rather of object B, ball B, when it's up while ball A reaches maximum height. I'm ready for 4.5. Let's do this. Obviously, guys, I have so much to do, but I do it in my classes, 250 for 5 lessons per month per subject, massive classes that we're doing. They're helping people. People are getting better grades, distinctions. People that were at level 1 are now on level 5, 4. We're now getting them to level 6, eventually level 7. Consistency is the key. You've got to give yourself to school. You've got to be focused. Whose problem are you going to be if you don't pass school? Whose problem are you going to be? You've got to dedicate yourself to schoolwork. Give yourself over and over to school. Consistency. Work hard. Attend classes. Watch videos. Check it out. Do extra classes. Anything and everything to make you pass. You are not at the position where you should be saying, I will tomorrow. You have no tomorrow. Actually, you are running out of tomorrows. Because you've been saying tomorrow, that's what you said yesterday. And today, you said tomorrow, that was yesterday. Today, you are saying the tomorrow of the tomorrow. You are running out of tomorrows. Soon enough, there will be no tomorrow, because that tomorrow is when you're writing the exam. And hey, boy, be ready. There's nothing as painful as getting into an exam and you have no idea what you are doing. You will see dizziness, thirst, anger, frustration. And what's sad is that the person next to you seems to know what they are doing. And they are drawing a graph. And when I don't even see a question that says draw a graph, Ntwana, prepare your life. 4.5. Let's prepare. Let's prepare. At what time in minutes will the speed of the two balls be equal? Oh, what a beautiful question. At what time in minutes will the speed of the two balls be equal? All right, let's get it done. So I would like to know, Uguti, during the movement of ball A, the movement of ball B, when are we going to have both balls with the same speed? In other words, I want to know the time when the velocity of ball A is equal to the velocity of ball B. I want to know when that happens. All right. So A and B are moving. Maybe let's start with the concept of A. A and B are moving. So A, you are moving. And it's yebo. And you have a velocity. Yes. And velocity is VI plus A delta T. Okay. So A, what did you move with? my starting was 5. Okay, sharp. And up is positive. So negative in that context, negative 9.8 and multiplied by delta t. So which means I'm at 5 minus 9.8 delta t. This is how you'd write the velocity of A in the movement. Angithi, it's starting with 5, yes, and it moves up, but eventually, obviously, it will move down as well. So this will be key to how I'm going to change it. So when it does that, it's 5 plus minus 9.8 delta t. Now, B, on the other hand, B moves up, and his velocity while moving up, same idea, vi plus a delta t. V started with 8, and then I'm on negative 9.8 multiplied by delta t. So for B, it's 8 minus 9.8 delta t. That's the final velocity of B, or the velocity of B, while this one is for A. Now hear me out and hear my logic for thinking. Now, we're looking for the time taken for the two balls to have equal velocity. The first thing we must acknowledge is that object A goes up, yes, but eventually comes down. The whole trajectory of B, as we see it, is an upward trajectory. It just goes up, B. And so we are looking for the time when the two velocities, E velocity of A is equal to the velocity of B. We're looking for that time, and in minutes, by the way. That's what they said. Hold on. Hear me out. Now, when A goes up, it covers 1.28 meters up. Yeah, we'll say. Then it comes down while the whole time B is going. Notice from the previous calculation, while A goes to its maximum height of 1.28, B only reaches a maximum height of 3.27. I think that was the calculation. 3.27. So B reaches a maximum height of 3.27. That's the best it does, B. But A would have gone 1.28, then eventually goes down. So logic and deduction would help me to understand, by the time that they have the same velocity, A should be going down. I will say that again. Yes. By the time they have the same velocity, A should be going down. B still goes up because A has a upward trajectory. So it goes up, then comes down. So the time when the velocities of A and B are the same, it's under the circumstance that A should be on its downward direction. If so, if A is downward, then down is negative. VF for A would be negative. All right, say. So Utiwena, these guys will reach the same velocity. UP is going up, and it only goes as far as 3.27 in maximum height. UA can quickly move 1.28, then come down. And when it's coming down, the velocity of A and B somewhere during the movement, the velocity of A and B will be equal while A is going down. All right. And then what? Hear me out and hear me good. I'm thinking negative bracket. The velocity of A is 5 minus 9.8 delta t. It is equal to E velocity of B, which is 8 minus 9.8 delta T. So then eventually I have negative 5 plus 9.8 delta T is equal to 8 minus 9.8 delta T. All you are looking for is time. So I can transpose our 9.8. I've got 19.16 delta T. In transpose with negative 5, I've got 8 plus 5, which is 13. And that's 0.66 seconds. But they wanted your time in minutes, which is now divided by 60. It's 0.011 minutes. This is the time taken for these two objects to eventually reach the same speed. And that becomes your answer. The more you do, hey, the more we know. The less we do, hey, the less we know. We do more, we will know more. We do less, obviously, we will know less. Just to re-explain this, listen to me carefully, please. Listen to this. So I needed to start off with the typical circumstance. When the objects are moving, there's a time that their velocities will be the same. So they move, yes, but there's a time when their velocities are the same. So when these velocities are the same, it means if velocity A, and I started with A, let's say VF VI plus 8 delta T, VI is 5, then plus A negative 9.8 delta T, which means this is the velocity of A. And I want A and B to have the same velocity. And then for B, same idea, 8 plus negative 9.8 delta T, blah, blah, blah. Now, by logic and extension, which is where I'm at, by logic and extension, we have been saying all this time, O up is positive. A goes up, then down. And I said, B, the best that it can do for its maximum height is 3.27. But OA goes 1.28, then immediately goes down. So logic and extension would mean the time when these two guys have the same velocity, it is when A is going down while B is going up. And if A is going down, then A's velocity is negative because down is negative. So negative velocity A, which is this, is equal to velocity B, which is going up. The rest is algebra, brackets opening. You see, let me show you where the problem is. If you said VFA is equal to VFB without considering the direction of A, you wouldn't get the answer. Because it would be now 5 minus 9.8 is equal to 8 minus 9.8 delta T. If you try to transpose negative 9.8 plus 9 plus positive 9.8 delta T, you get 0. And it doesn't even make sense. So the velocity of A has to be the velocity of A going down, logic and deduction, so that they can have the same, or rather they can meet after 0.66, where their velocities are actually the same. I say this now, I say this forever. The more we do, the more we know. Thank you so much for joining the class. You guys have been amazing. As always, I hope you learned, and I hope you remember how things are in this context. I'll be doing some more free classes, but not all the time. But remember, every single month, I do topic after topic after topic. I see some of you saying, yo, electricity. I did it with my grade 11s. I see some saying, your electrostatics, I did it as well. All these are grade 11 topics. They are coming. I have videos for them. Just in case you want videos, you can always buy them as well of these topics and this beautiful stuff that we learn right there. In Africa, in South Africa, when someone does something good for you for free, we say thank you. Siyabonga. When someone does something for you for free, you say thank you. So the lessons are $250 per month per subject, and that's basically what you're going to have from there on. Then I'm also doing revisions. Currently, I'm doing a revision. I've done paper 1, which was done on Wednesday, yesterday. Then Monday, the 15th of June, I'm going to be doing paper 2, organic chemistry, rates of reaction, chemical equilibrium. It's about to go down. It's going to be 5 hours. If you want to join the Monday revision, you're just going to pay $125 because the whole 10 hours was $250, but I'm done with paper 1. If you want the videos of that, you can buy them as well. But if you want paper 2, which I'm going to be doing, organic chemistry, rates of reaction, and chemical equilibrium, $125. Very importantly as well, I have massive revisions that are coming up. Oh, guys, there will be fire on fire on fire. That's what you'll be doing when you do the massive revisions. Imagine if you learned as much as you did in the 2 hours now. Imagine when we're now doing the revisions. So they're going to happen in the prelim. I'll update on the dates, but it's going to be 20 hours, 10 hours paper 1, 10 hours paper 2 online for the prelims. For the finals, it's going to be 25 hours for online, and it's going to be 40 hours for the face-to-face. So for the finals, there's 2 options, face-to-face as well as the online ones. And these are the dates. I'm going to be giving you the dates as soon as I can, as well as how much it's going to be, but very, very affordable. Because again, I say to you, the more we do, the more we know. Thank you. You are appreciated.